examples now in normal approximation to a binomial. So the first is, we are going to see this and then we shall handle this after. But this need to be out in tables because we are going to use some table. So here, an examination has 100 questions. And you know now this now is going to be our end. So as you read, you summarize also the question. So an exam has 100 questions. So our end is 100. A student has 60% chances of getting it correct. So now our probability is getting something right. So the probability of success P is 60%, which is the same as 0.6. Means that if this is 0.6, then the probability of failure is 0.4. A student fails the exam for a mark less than 55. A student gets a distinction if he gets a mark of 68 or more. Find the probability that the student fails an exam. So here I know that standardize this within our mean. So our sigma mean is, our mean is given by NP, which will be given by 100 times 0.6, which will give us 60. So that's our mean. We also need our variance. So the value of x or the sigma, our sigma is squared, you can get sigma squared, you can get value of x, it's up to you. So our sigma is going to be a root of NPQ, the standard deviation, which will be we multiply now our n, which is 100 times 0.6, then times 0.4. And so here our sigma C, it's going to be, when you get it, you get root of 24. So this will be root 24. So now after that we have got the approximation information in the question. So after we come to fails the exam, and they told that someone fails the exam for a mark less than. So the probability that someone fails an exam is when he gets a mark less than 55. But we say, because this was information for a discrete, we convert it now to a continuity using a continuity operation. We shall now say if it's less, then we subtract 0.5 from this. So this will be probability of x less than 55. Then minus 0.5. This is what we call the continuity correction. And so this will be the probability now of x less than 54.5. Now we standardize this. Now this is now in continuous, and so we standardize it. Standardize it, we say that we standardize it. The formula we are using in standardizing, we say it's given by our z. Our z is given by x minus NP over root of NPQ. So now, putting it here, this will be now probability. Now this one becomes Z. This one is going to be now less. Minus NP. Our NP is 60. The whole over sigma, the root of this, root of NPQ, which is root 24. This is root 24. Then you press your calculator. This is Z less. It's going to give us here I'm getting negative 1.123. You said you give these ones with 3 decimal places. Then after doing that, you come and do your sketch, a simple sketch for this. How is it going to be? You start the one Z. This is now the value of Z. You want to get the probability. So a very simple sketch like this. Then you indicate that it's negative, so it's going to be here. Negative 1.123. I want it to be less, so this is the probability I'm looking for. This is my 0. You get your table and then you look for this value. This will be the value. This is the same Z. This is the same as probability of 0.5 You say this is P, and this is the same. This will be 0.5 minus P. So you say this, then minus probability of 0. Less. Now magnitude negative 1.123. This will be 0.5. Now minus. We press now that the positive of that calculator. Or I told you read the tables. After reading the tables, the value you will get is 0.3693. And you subtract. Answer you get 0.1307. Now we come to this one where they want gets a distinction. Part B gets a distinction. We said someone gets a distinction if the mark he has is of 65 or more. 50, 65, and 68 or more. This is the symbol. And now we said we combine now these two continuous and probability of x greater or equal to. Say if it's greater or equal to, then we shall subtract 0.568 minus 0.5. And so this will be now probability of x greater or equal to. Now this is going to be 67.5. So we standardize that, which will be now the probability of z now greater. Say the only thing we have is greater if we have z, then this is our x. 0.5 minus 60, the whole over our sigma, which is the root 24. Then when we press this, our z is going to be greater than, we read that, 7.5 divided by, I'm getting 1.531. And now when you sketch this, you start, this is how your probability will be now. This is positive, this is 0, so your 1.153 is here. These are values of x. So, we started here, we say you get 0.5 then minus that probability, which would be 0.5 minus now the probability when from here up to here. That's 1.531. And subtract that, we get 0.5, then minus. Press that on the calculator, and then when you read the table, you get 0.4371. And the subtract. We get 0.6, then 0.0629. That is our probability there. And then after that, we come to this next question. They are telling us that on average, 15% of eggs, boiled eggs, have a crack. So means that now their probability of success is for an egg to be with a crack. Find the probability that a sample of 300, so now they are giving us n and 300, our probability of success is for having a crack, which is 0.15. Then our probability of failure will be when we are having, when we don't have a crack. So you get this minus 100, which would be 0.85. Or you get 1 minus 0.15, that's what you get. So find the probability that more than 50 cracked eggs, So our probability is our x, the number of cracked eggs, more than 50. Now we say we must convert that to a continuous, which will be probability of x greater than, it's greater, we say we add 0.5, which will be probability of x greater than 50.5, as simple as that. Now after that, now you standardize this. You say this is the probability now of Z greater than 50.5. And you can take our mu. Our mu, we say is NP, which will be 300 times 0.15, which will be, I think, 45. Then our sigma will be square root of NP, which is 45 times 0.85. And our sigma will be root of 38.25. So then minus me down over roots of 38.25. And when you simplify this, our Z is going to be greater than here I'm making better than 0.889. Then after that, when you state this, is that these are values of Z. We want the probability. So my Z above is positive, so it's going to be this side 0.889. So it's positive. I want it above that, which we say is the same as 0.5, then minus probability of 0 less than less 0.889, which will be 0.5, then minus, when you read that probability from the table, you get 0.313, and if you subtract that, we shall get 0.187. That's how we have. So that's how we have. The most important thing here is get the number of priors, get the probability of success, get the probability of failure, and then attach the sigma, now the standard deviation, attach the mean, then substitute as you see. But we shouldn't forget that this one is the first do opportunity correction. If it's less, you subtract it's this and so on. So that's it, members. I wish you